You've seen them, right? Those grainy black and white images from an ultrasound? It's like a little window into the human body. But have you ever stopped to think about the insane technology that makes it all possible? Well, today we're going to dive deep, because we're about to uncover a symphony of physics and engineering, all playing out on a stage smaller than your fingernail.
It really all boils down to this one question. How in the world do we turn invisible sound waves into a detailed, moving picture of what's inside of us? I mean, it sounds a little bit like magic, doesn't it? But it's not. It's actually a masterpiece of incredibly precise, high-speed coordination.
Okay, so the basic idea is pretty simple. The machine sends out a sound pulse, and then it listens for the echo. You know, kind of like how a bat uses sonar to fly around in the dark. But seeing a single object is one thing. Creating a whole, detailed, two-dimensional image, that requires thousands of these pulses, from tons of different sources, all working together in perfect harmony. And that, my friends, is where things start to get really complex.
To solve this problem, engineers came up with a truly brilliant idea. Instead of using one big noisemaker, they use a whole array of tiny, tiny sound sources. The best way to think about it is like a microscopic orchestra, where every single musician has to play their part absolutely perfectly to create one focused masterpiece of sound.
So, how many musicians are in this orchestra? Well, in the kinds of advanced systems we're talking about today, the probe uses 32 individual sound sources. That's right, 32 musicians, and every single one needs to be perfectly synchronized.
Now, as you can probably imagine, getting 32 musicians to play together is, well, it's really, really hard. They need absolutely flawless timing, they have to produce the exact right sound waves, and they have to focus all that sound to a single point thousands and thousands of times a second. Without a leader, all you'd get is a bunch of noise. You need a world-class conductor.
And that brings us to the real hero of our story. The solution to this massive coordination problem isn't a person in a tuxedo. It's an astonishingly powerful microchip. This little thing is the tiny brain that acts as the conductor for our entire ultrasound orchestra.
Okay, its official name is the STVUP32. Yeah, I know, it's a mouthful. But let's just break down what that means. 32 channel, well, that means it can conduct all 32 of our musicians. High voltage and high-speed pulsar means it tells them exactly what note to play and with how much oomph. And then there's the magic word, integrated beamformer. This is its superpower. This is how the conductor focuses all that sound.
So you can kind of think of this as the conductor's resume. Its technical specs translate perfectly to our analogy. The 32-channel pulsar, that's it conducting all 32 musicians. The waveform generation, that's like writing unique sheet music for every single instrument. The integrated beamformer, that's its secret technique for focusing the sound. And the power management means it's an incredibly efficient conductor, which, as you'll see, is a total game changer for modern devices.
So let's zoom in on that one key skill, beamforming. This is the conductor's true art form. It's the technique that turns what would be a chaotic blast of sound into a precision tool. It's the difference between just shouting at a cave and using a laser pointer.
The concept is almost poetic. See, instead of having every musician play at the exact same time, the conductor introduces these microscopic, perfectly calculated delays between each one. These tiny little offsets cause the individual sound waves to interfere with each other in a very specific way, channeling all their energy into one single, focused beam.
Here's how it works, step by step. The musician on one end of the line plays its note. Then the one next to it plays, but just a fraction of a second later. This continues all the way down the line, a perfectly timed cascade of sound. What happens is, the resulting waves all add up and reinforce each other in the forward direction. And that's what creates that sharp, steerable beam. Pretty cool, right?
And the scale of these delays is it's staggering. This little STVUP32 chip controls the timing down to just 5 nanoseconds. That's 5 times billionths of a second. It's that kind of incredible precision that allows us to create such crystal clear images.
So why does all this matter? I mean, what's the real-world impact of having such a powerful little conductor on such a tiny chip? The answer is simple. It has completely, and I mean completely, revolutionized the ultrasound machine itself.
It really wasn't that long ago that ultrasound machines were these huge room-sized consoles. They were ridiculously expensive, they were power-hungry, and they were stuck in one room in the hospital. But by integrating the conductor, the whole beamformer and pulsar setup, onto a single chip, we can now build devices that are ultra-portable, super power efficient, and can be used right at a patient's bedside or even in the back of an ambulance.
And listen, this isn't some far-off sci-fi tech. The datasheet for this chip lists its applications right there in black and white, from standard medical imaging to the next generation of ultra-portable devices, and all the specialized drivers needed to make them work. This technology is already out there, right now, making a huge difference.
And here it is. Here's the detail that just puts it all into perspective. The entire conductor, the whole brain managing this 32-piece orchestra with nanosecond precision, is housed in a package that's just a little over 1 centimeter square. It is an absolutely incredible feat of miniaturization.
So the big takeaway here is this. The next time you see an ultrasound image, just remember the symphony that's happening behind the scenes. You've got a full orchestra and its conductor performing an incredibly complex piece of music at unimaginable speeds, all on a tiny silicon stage. It is a true marvel of modern engineering.
This really leaves us with a fascinating question for the future, doesn't it? As this technology keeps getting smaller and cheaper, it just opens up a whole world of possibilities. When a device that can literally see inside the human body fits in your pocket, where's it going to show up next? In every doctor's office? In every ambulance? The possibilities are, well, they're truly transformative.